Today we're going to talk about your third shape for conics, which is the ellipse. So remember that before we have talked about a circle, which has x squared plus y squared equals r squared, and we said that the radius is the square root of that r, and it's the same in any direction. An ellipse is like a circle, except that instead of being the same in both directions, it has differences. So this difference here and this distance there will be different. And you can have ellipses that are horizontal, meaning like this one here, they go side to side, or that run up down. Your major axis is always going to be the longest one. So this one, since it's longest side to side, that's our major axis. But this one, as it runs up down, is the major axis. And then the minor axis is just that shorter distance of it. So since we have two different distances for up, down, and side to side, instead of having an r squared at the outside like a circle, we'll have numbers underneath the x and the y to tell us how far they went. Since this is the horizontal distance, that's going to be connected to the number underneath the x. And the picture on our right here, the horizontal distance here, will be the number underneath the x. The a's and the b's simply mean which number is bigger, but the horizontal distance, whether it's blue or whether it's yellow, always goes underneath x. The vertical distance, again, whether it's blue, like here on the left, or whether it's yellow, like here on the right, go underneath the y. A will always be the larger number, so that can just be a note for yourself. A is always bigger than B. And so you don't need to memorize these both forms of the equation. You just need to recognize that when the larger number is underneath the x, then you'll have a side-to-side ellipse, like this one, a horizontal. When the larger number is underneath your y, you'll have an up-down one. Well, that's a really bad picture. There you go. No better. That's okay. Typo here, it didn't really show up in your notes, but these do still have squareds on them, x squareds and y squareds. Now, both of these are centered at the origin, because there's no h and k connected with the x and the y. We'll see some a little bit later that do have a different center. One other thing that you need to memorize is this formula here gives you the c value. And remember that c gives you the distance from your center to the focus. Okay, the distance from your center to the focus. Now, parabolas had one focus. Ellipses actually have two. So these guys out here are focus points. And again here. You'll notice that the focus points always run along the major axis. All right, let's practice doing some equations and some graphing, so hopefully you can get the hang of this a little bit. So we talked about the major axis, which is the longer segment, and it contains the foci. That's how you say this. Foci is how we say that. And the shorter axis is the minor axis, and then you have the center, which falls right in between. So write an equation for each ellipse. First of all, we have to know the center. So for this first one here, we're centered at the origin. And then we need to figure out the distance from the center out to the side. So this is 3 units. And the distance upwards from the center is 2 units. So in our equation, since the center is 0, 0, it's going to be x squared over something plus y squared over something. There's no h and k. And an ellipse is always equal to 1. The 3 over here, since it's horizontal, is going to go underneath the x, so 3 squared or 9. And then the 2, running up and down, is going to go underneath the y squared, so 2 squared or 4. So we could write this, or we could say it's x squared over 9 plus y squared over 4 equals 1. That's the standard equation for this ellipse. For this one over here, on this side, we have a center again at 0, 0. This time we're going 1, 2, 3 units upwards and 1 unit outwards. So we'll have x squared over a distance of 1 squared plus y squared over a distance of 9, or 3 squared, and this is equal to 1. So again, there's our standard form. All right, as we're graphing these, make sure that your equation is always in standard form, meaning that you always have a 1 on that one side. You're going to look for the center, and then you're going to want to make sure that you take the square root of the numbers in the denominator. Those will tell us how far to stretch our ellipse horizontally and vertically. And then we also have to make sure that we find the c value. So to calculate c, this one here, we said it was c squared equals a squared minus b squared. So this is the square root of a squared minus b squared, where a is always the bigger number. This will tell us how far to move along the major axis. It is the distance from the center to the focus. So we'll see that pop up. All right, so for our first one here, it is equal to 1, so we're set to go. Our center is 0, 0, since there's no h or k with that. And the number underneath of our x is 4, so that means that it will be 2 units to the side, and the number underneath y is 9, so that'll be 3 units. Remember, square roots. The larger number is always a, and the smaller number is always b. So center at 0, 0. 3 units vertically up and down, and 2 units horizontally side to side. Connect these, make your ellipse shape. There we go. And then we want x-intercepts and y-intercepts. So this is where it touches the axes. X-intercepts will be at 2, 0 and -2, 0. Y-intercepts will be at 0, 3 and 0, -3. Foci, we're going to have to make sure that we come down here to find this. This is c equals the square root of a squared, so 9, larger number, minus the smaller number 4, which is square root 5, which is about I think it's 2.24, so a little bit more than 2. This distance is from the center, and it always runs along the major axis. So in our ellipse here, the major axis is running up and down. So this point is going to be 2 and a little more away from the center. So 1, 2, and a little bit further, and 1, 2, and a little bit further. So not quite at the edges, but close. When we talk about writing these as points, please use the exact answer. The decimal is just to help us with the graph here, but you want the exact answer in your point. Notice that because we're on the major axis running up and down, on our center we are not changing the x coordinate. That stays the same for these 2 points. So it's 0 and 0 up and down. And then we went from this part, how much? We went 0 plus square root 5 units up and 0 minus square root 5 units down. So 0 plus square root 5 is just root 5. 0 minus square root 5 is negative square root 5. And then the length of the major axis is 3 units up and 3 units down, so it's 6 units. All right, this example is not set equal to 0, so we have to divide by 144. And if you divide one side, you have to divide the other side. So this cancels. We get 1 equals. 16 goes into 16 once, so we have 1x squared. 16 goes into 144 9 times. 9 goes into 9 once, so we just get y squared. 9 goes into 144 16 times, so this is our standard form. Our center then is going to be 0, 0 still. And this value here, the square root is 3. And this value here, the square root is 4. Bigger number is always a. Smaller number is always b. So from our center, 0, 0. 4 units up and down because it's underneath the y value. 3 units out to the side. Connect these to get our ellipse. So list your x and y intercepts. -3, 0, 3, 0, 0, -4, 0, +4. calculate your foci, so you have to get your c value. C equals the square root of larger number minus the smaller number. So square root 7, which is about 2.65. Again, on the major axis, so 2 and a little bit more up and 2 and a little bit more down. To list these as points, look at your center. We're not changing the x. We're not moving side to side, so these ones will be the same. So this one will be 0 and 0. And then we are changing the height, and we're going to say we went from 0 plus root 7 and 0 minus root 7. And then the length of our major axis will be 4 units and 4 units, so 8 units. Okay. All right, this next one is different in that we finally have a different center going on here. We have a center at positive 3, comma, positive 1. Remember, it's always opposites inside parentheses. This here will be a 3, and since it's the smaller number, that'll be our B. And this one is our larger number, 5, will be A. So from our center, 3, comma, 1, we're going to go vertically 5 units. 1, 2, 3, 4. 1, 2, 3, 4, 5. And side to side, horizontally 3 units. Connect these. Notice I'm not asking you for intercepts on this one because they don't cross at super nice places. So we'll skip those and just move straight on to foci. C equals the larger number minus the smaller number, which is square root 16, so just 4, which is really kind of nice here. Major axis is still running up down, so we want to go 4 units, 1, 2, 3, 4 units up, and 1, 2, 3, 4 units down. And then in our center, we'll still be on the 3 for our x because we went up down, so that doesn't change. But we are going to change this value. So we're going to say 1 plus 4, which is 5, and 1 minus 4, which is negative 3. And on your graph, sure enough, this one here is 3, comma, 5, and this one here is 3, comma, negative 3. Length of your major axis is 5 plus 5, so 10 units. And last graphing example. This one looks a little different than ones we've seen before because as you're looking at the pieces underneath here, this is the first time the larger number has been underneath the x. So our A will be 4 horizontally, and our smaller number here, B, will be vertically because it's underneath the y value. Center is at negative 2, comma, positive 3. And then horizontally is 4 units. And vertically is 3 units. Connect these. Foci, C equals square root of 16 minus 9. So square root of 7, we just had that. That's like 2.65. So go out 2 and a little more units along the major axis and 2 and a little more units along the major axis. For our points, we're not changing the y's in this point. They're still at the same height. So they will have y coordinates of 3. We are changing their x values, and what we're changing is we're saying we're at negative 2 plus root 7. That gives us the 1 out here. And we're at negative 2 minus root 7. That gives us this one here at the back. And then the length of our axis will be 8 units long. All right. When we're identifying features, again, remember that a circle has positive x squared and y squared terms. With an ellipse, they have different coefficients, whereas a circle, they have to have a coefficient of 1 or the same coefficients. So let's go through and let's try to identify what we can here. We're looking for either a circle, a parabola, which has only 1 squared, an ellipse, or none of these. So in our first one, we notice that there's only a y squared, which means that this is a parabola. In our second one, we notice that there's a minus between them, so it's not positive, therefore it's not an ellipse, it's not a circle, it's none of these. This is the fourth shape we'll learn about tomorrow. In our third example, they have different coefficients. This one has a 3 and this one has a 1, so this one is an ellipse. And then in this one, they're both positive. They both have coefficients of 1, so this is our circle. And you're done.